Okay, so today in class you worked on writing the equation for a circle given 3 points, and today we're going to look at how to find the equation for a tangent to a circle at a given point. You would start by coming up with the equation for a circle with a center. This one has a center at 0, 0 and a radius of 5, and it says to sketch your circle. So it would be x minus 0 squared, which is just x squared, y minus 0 squared, which is y squared, equals the radius squared. So r squared is 25. So there's the equation for our circle, and then we would sketch that equation going out 5 units in each direction, and then to the best of our ability we would draw in a circle. My circle is a little lacking. Hopefully yours is a little better. So, is the point 3, 4 on the circle? Well, it appears, according to mine, it is. So, yes, it does look like it is, but since my circle is not drawn perfectly, the best way to know is to just plug that into the equation. So we do 3 squared plus 4 squared. Does that equal 25? And 9 plus 16 is 25. So yes, I know that it does fall on the circle, even if my drawing is a little shy of perfect. So now we're asked to draw a line from the center of our circle to that point. So we're going to come in here and draw a line from the center of the circle to that point. So this is what we'll do. Got it in there. Okay. And then write the equation for this line in slope-intercept form. So it's y equals mx plus b. And so since my b is 0, and my slope is up 4 over 3, that is y equals 4/3 x plus 0. And so do we even need the plus 0 part? No. Y equals 4/3 x is fine. Then it asks us to draw a tangent line. Well, a tangent line is a line that only intersects a curve in exactly one point. What would the tangent line to your circle look like at this point, 3, 4? Draw in the tangent line at 3, 4 on your sketch. So we know a tangent line intersects in only one point, and I'll switch this to green. And let's see if I can draw in something that looks tangent. That's kind of tangent. It's a little off. And it would be going just through that point. So mine's not perfect, but it's close. Alright, we should notice that when we draw in this tangent line that it is perpendicular to the radius. So when it is perpendicular to the radius, what does that tell us about the slope of that line? Well, if it's perpendicular, we know perpendicular slopes are opposite reciprocals. So the slopes are opposite reciprocals. So if the slope of the line going from the center to that point was 4/3, then the slope of the tangent would be the opposite sign, negative, and reciprocal. So the slope of the tangent line should be negative 3/4. And we know that tangent line is going to pass through the point we want it to pass through, and the point that it passes through is 3, 4. So now we have the slope of this line, and we have a point that it passes through. So when you're given a point and you're given a slope, you should use point slope. Y minus y1 equals m times x minus x1. And we'll plug in our slope. We'll plug in our point. And we are done. Okay, you have a U-try to try now. I'm going to go ahead and post the solution for that U-try, so you can check it if you'd like. And then there are 3 problems that you'll be working on in class tomorrow.